Yeah. You do?
All right, so this is the brew house area. A little bit about the brew house. This is most of the equipment that we have here at Free State Brewing Company was purchased used. Great thing about brewing equipment, if it's taken care of, it lasts a good long while. It's generally made of stainless steel, and this was commissioned by Widmer Brewing Company in Portland, Oregon, back in the mid '80s. And I believe it was commissioned in 1988, and we opened in 1989. Well, they used it for 20 plus years, and then we purchased it in 2008 and brought it here. It's a 40-barrel brew house, so theoretically we can produce 80 kegs worth of beer in a given batch from one batch. Once we've milled the malt into grist and we've recorded our temperature, we then have to decide, okay, how much hot water are we going to add to the malt to hit our target temperature? And so the brewers will calculate that. They'll say, I need to target 152 degree rest temperature, and my grist is at 60 degrees, so I need to strike my water temperature at this temperature. They'll figure that out, and they'll take hot liquor, which is, we use a lot of jargon in brewing. So anytime we use water in the process in brewing, it's called liquor. So we use hot liquor and cold city water that's been filtered and hydrate the grain as it's coming through this auger above our heads and into what's called the Steele's masher, which is yet another auger that spins and helps to hydrate the grain on its way into the mash tun. Once it's in the mash tun, there are rakes that are constantly turning inside the mash tun. They're pushing the grain around the mash tun so that there's a nice even bed inside the mash tun. The reason we want that even bed is that there are a set of screens right about here that act as a giant strainer. There's liquid entrenched in that mash because we've hydrated it, and initially that grain is very turbid. It's not, it's kind of milky looking, and it doesn't have a lot of sugar content yet because the sugar has not been converted during the mash process. After about 10 minutes, you start to see sugars being converted, and you also, we do a process called vorloffing. It's a recirculation process where we take liquid that collects below these screens and pump it back up to the top and back onto the top of the mash. And we do that for about half an hour. During that time, that wort that was initially very murky looking will start to clarify. That's one of the reasons that we wanted that husk to remain largely intact, because that creates a filter bed for the mash water and the wort. So that process takes about half an hour. At this point, we're ready to start sending the liquid over to the kettle. So this middle piece of equipment here is called the kettle. It takes about an hour and a half to 3 hours, depending on the brew, to transfer liquid from the mash over to the kettle. Now there's not enough liquid in the mash to fill the kettle, so that entire time we're doing a rinsing process as well, where we take 170 degree hot liquor and rinse the top of the mash, and we're basically replacing the same volume of water or liquid that's being pulled out of the mash with hot liquor, so that there's equilibrium. Once we get 40 barrels in the kettle, we hit a boil, and we have a steam-fired, this This kettle used to be gas fired, so there used to be a firebox on the bottom of it with a giant flame, like a big cauldron, you know, almost like a big gas burner on your stove. But we converted it into a steam kettle, so now the wort gets pumped through a heat exchanger that has steam on one side of the heat exchanger, and on the other side it has wort pumping through it. We do a number of different things when we boil the beer. There's bacteria on the malt that is not bad for you, and it couldn't harm you, but it would spoil the beer. So we want to sterilize the wort so that we're ensuring that that doesn't make it to the fermenter. We're incorporating hops during that time. Hops are the spice in beer. So hops are a flower that grows on a perennial vine. Most of the hops that we use are American hops, and most of the hops that are grown in the U.S. are grown in the Yakima Valley in Washington State. And you'll see pictures later on. We have a little slideshow going over in the bottling hall, and you'll see pictures of malt being produced and hops on the vine. So when we get the hops, they're actually pelletized. So they've taken the flower of the hop, they've pulverized it, and then pressed it through a die, so it looks just like rabbit food to us. That keeps it a lot more shelf stable, and it's a lot easier for us to use in our processes. So if we add hops early on during the process, we're going to get more bitterness from the hops. If the later that we add it in the process, the more aroma and flavor we're going to get from the hops. So for instance, a beer like Yakimaniac that we try and emphasize hop flavor and hop aroma, we don't add a lot of bittering hops to that brew. Most of the hops get charged in what's called the whirlpool, which is the third vessel in this brew house. The whirlpool is where we send the wort after it's been boiled. So it comes into this container at a tangent. There's a valve kind of a third of the way up, and it gets pumped in, and it creates this vortex. And that vortex is important because all the solid materials that are in the boil, some proteins that have been denatured during the boil, and the hops that we did add to the boil, and the hops that we add to the whirlpool, all start to collect in the center of this whirlpool. And that enables us to draw off liquid from the side of the whirlpool so that we're leaving a lot of that material behind. We don't want that to go to the fermenter for a number of reasons. A, it won't be good for the flavor, and it'll reduce our yields. So once it's in the whirlpool, it's ready to start sending over to the cellar. Now, when we send it over to the cellar, we're going to pump it through a heat exchanger, and on one side of that heat exchanger we have cold liquor traveling through the heat exchanger, moving in one direction, and in the opposite direction on the other side of the heat exchanger is our hot wort that's at over 200 degrees Fahrenheit. Yeast would not survive that 200 degrees Fahrenheit, so we need to cool it down, and we're able to dial it in to the temperature that we need for fermentation. So if we're producing a lager, we're able to dial it in to 54 degrees, and the wort, once it hits the fermenter, is 54 degrees. Likewise, if we do an ale, we'll be able to target 67 degrees and hit it. During that time, we're also oxygenating the wort. It's the only time in the whole process that oxygen is beneficial to the process. At every other point when we're brewing and packaging, we're doing everything that we can to eliminate oxygen. But there's this one stage where oxygen is important to the health of the yeast in the initial stages of fermentation.